We've all had this happen before, where we ask around for lead and no one has any of the right size. So you end up losing the pencil. Because so many mechanical pencils are either lost or thrown away, this has caused a lot of pollution because the pencils are made out of polyester plastic, and this all goes in the environment. Knowing this information, we then took a survey from students in our own school, and a majority of them experienced losing pencils or throwing them away because they ran out of the lead. We found 0 patents on this problem, but we did find one solution that contained a 3-hopper system, which was too clunky. So we then came up with design criteria such as the pencil has to be lightweight, durable, has to have 1 hopper, and it also has to adjust to different size leads. Here are the team's designs. They all variate the tip of the pencil and change how lead is dispensed. So after narrowing down all of our options, we decided to use a drill chuck system which will clamp onto the lead and can change the size depending on what lead you want to use. Now we have come to the prototyping. So basically days 1 through 3 was designing, and on day 1 we actually had to learn how a drill chuck system works. So we downloaded a 3D model drill chuck off the internet and we tried printing that, but it didn't work. So after lots of trial and error with that, we actually decided to create our own drill chuck system. Now from days 4 through 6, we actually had to branch apart and see what we could do as a team rather than just working on one design at a time. So we decided that we'd make our own things, and Carter made a Lego system, which ended up being an actually really cool concept of what we needed, and Andrew and I created 3D models, or at least I tried, but Andrew actually created the best 3D model, which we ended up using for our final prototype. So for the remainder of the days, we just printed Andrew's design over and over again till we perfected and eventually created the final product. It took a lot of fitment and adjustments to the 3D model itself, and this lasted several weeks. And this was not easy because the 3D printers failed a lot, and we had a lot of trial and error with the 3D printers, and ultimately we did have success. The final product is actually really good, and now we'll talk about the testing procedures that we used on our drill chuck pencil bit. In our testing procedure, we used a wooden dowel and a metal bit and stuck them through the drill chuck to see if they could clamp, or if the drill chuck could clamp onto those things. And it actually succeeded in doing so. Here are the STEM principles that we used throughout the entire project. To reflect on the entire project, it wasn't easy because we ran into a bunch of problems with 3D printers and designing, but we learned a lot. And also, we didn't really create a new mechanical pencil of anything like that. We actually created a new type of drill chuck system that can allow items to pass through the center of it and clamp onto it that way. Now, if we wanted to do a mechanical pencil that adjusts to 3 specific sizes, then we would measure how big the actual clamp needs to go in order to clamp on specific sizes of lead or anything of that sort. It was also hard because we didn't have any reference points to use. There were no patents that existed, and previous solutions weren't good enough, and they weren't of what we were thinking originally of what we wanted to do with the mechanical pencil adjustability. There was a point in our project where hope was lost. It really was, because we couldn't come up with an actual design because of the 3D models not fitting so much, and because the 3D printers kept failing so much. And we really got a glimpse of hope when Andrew created a great model that actually started fitting. And not only that, but we also had a backup plan with Carter's Lego design, which was really great in case we had to do a proof of concept instead of creating an actual design. So after we finally created our final design, we were able to test, and this was the easiest of the steps because it went so smoothly and we were able to complete that with ease.